Welcome. Today's lesson is on significant figures. Well, any science or math that has to do with any kind of accuracy or precision is you're going to have to, at some point in time, run across significant figures. We call them sig figs. And significant figures essentially is a way in which we can measure things, whether it be a temperature or whether it has to be volume or a length. So all of those things may have to require significant figures. Significant figures are digits within a number that determines accuracy as well as precision. So what does it measure? Well, let's take a look at this thermometer that I have. And as you can see here, it's measured in degrees Celsius, and this happens to be 38. The long black line there represents 38 degrees Celsius. But this particular temperature, as you can see, is at 38.2 degrees Celsius. So each one of the little lines is a very accurate line. So it's very accurate to essentially a tenth of a degree. But rarely does it always fall just right on one of those divisions. Sometimes it goes in between them. And when it does that, you have to kind of guess. You have to estimate. And this one, it looks like it's about 5/100ths of a temperature. So it's 38.25 degrees Celsius. And really what we're measuring when we measure that is significant figures in any kind of a measurement includes the known digits, which is 38 and 0.2, plus a final estimate digit. And that was the 0.05 that we put in there. So that's a significant figure. It measures all sorts of things. And anytime you need precision or accuracy, that's what we're going to be using. But there are some rules. Now, don't get all worked up and flustered. Really, the best thing to do is not try to memorize them, but use them on a regular basis. And it takes some time, so you're going to have to probably watch this video and maybe another one, but also definitely do the problems. The problems are the thing that allows you to kind of set it in your mind. So there are three of them. The first one says all numbers that aren't zeros are significant. For instance, this 544, how many significant figures does it have? Well, it has three. It has a 5, a 4, and a 4. All numbers that aren't zeros are significant. So all of those are significant. Now, this next one essentially is any zeros that are in between non-zero numbers or sandwiched together. Those non-zeros are significant. So long as they're packed inside or bookcased between non-zero numbers, you've got a significant number. So in this case, 7,041 is 4 significant figures. So far, so good, but it starts to get a little bit tougher as we go along. Now, zeros after a decimal are significant. So even though the zero is at the very end, but because it's part of a decimal, 48.30, it still counts as a significant number. So in this case, it's 4 significant figures. Zeros and coefficients in scientific notation are significant. Really important about that, because when we start looking at moles and percentages, you're going to need to know what a scientific notation is. For instance, this one is 47.0 times 10 to the 3. 10 to the 3, basically, it means you multiply it by 1,000. So in this case, if you take a look, you kind of disregard the scientific notation part, the 10 to the third. Just block that out. So you have 4.70. That means there's 3 significant figures. So you really don't just kind of ignore the whole 10 to the whatever, because you're just looking at basically the numbers on the left. Now mark this, rewrite this, put it up in blinking lights, circle it, whatever you need to do, because these next two are kind of important. Well, not kind of, they are important. But a lot of times you'll miss out on this. Leading or beginning zeros are not, I repeat, not significant. So 0.0083. How many zeros are there? There's 3. Are they significant? No. So how many significant figures are there? Dos. That's right. 8 and 3 are your significant figures. And then lastly, zeros in a large number. Now, underline this. Put shiny lights on it if you have to. Zeros in a large number without a decimal are not significant. Zeros in a large number without a decimal are not significant. Like this number, 600,000. How many zeros does it have? Count them. That's right, 5. How many of them are significant? None. Just like a 0. None. So you have one significant number, that being 6. Well, it's not too hard, but you got to practice. You just got to practice. If you don't practice this over and over and over again, and so in the show notes or in the description, I will have a link to the website so you can download some of those practice problems. I would suggest you do that. So let's do a couple practice ones anyway. So if you're adding or subtracting, there's a kind of a different rule. First of all, you're looking at the least amount of decimal places. So if we let's just take some of these, and the next thing that you do is you line them all up, have all the decimals line up in a nice line so that all the columns are where they need to be. You add them up, obviously, and then when you add them up, and this one is 1,296.46. Now, of all of those three numbers, the 1,013, the 276.32, and the 7.14, which one has the least amount of decimal places? Yeah, the very first one. It's got none. So this makes this problem kind of easy because we're not looking to go to any kind of decimal. So what we're going to do is our answer is going to be 1,296. See how simple that is? Look for the least amount of decimal places. Let's look multiplying and dividing rule. Look for the least amount of significant figures. The other one was decimal places. This one is look for the amount of the less amount of significant figures. So we're going to take 7.25, which has 3 sig figs. We're going to multiply that by 37.267, which has, that's right, 5 sig figs. We're going to multiply those together. We get this humongous number, 270.18575. So when we multiply this to get the answer, which one of the significant figures do we want? The most or the least? Well, yeah, it says the least. So we want 3 significant figures. So when we do our calculations, that's 8 sig figs. The answer would be, that's right, 270. Notice I put a decimal next to it on the right. Why? Because if I didn't, it wouldn't be a significant number there. 0 wouldn't be significant. It has to have that decimal. So the correct answer is 270 point. So at the decimal. So that's how you do the multiplying and dividing. Let's see how good you are in this. So on 540, what is a significant figure? How many significant figures does it have? If you said 3, you'd be wrong. Because if you look at 540, zeros are insignificant. They don't count in significant figures. So it only has 2 significant figures. Well, that would be 5 and 4. In this case, it has 96.20. Now, the first one, remember, all non-zeros are significant numbers. Zeros aren't significant, so that's why that was 54. Now, in this one, this says a 0 at the end. Is it significant? Well, no, it is because it isn't, because zeros after a decimal are significant. Zeros after a decimal is significant. So in this case, it would be 4. Now, 200, that should be easy, right? It has how many? Yeah, I didn't think I could put this one over on you. You have 200, but you don't have a decimal, which means zero's gone. Insignificant means 2 is a significant figure in this case. Now, in this case, if you take a look, you'll notice that it's 0.005. Now, also notice I also put the scientific notation on it. So, what would be the significant figure? Because if you just look at the 0.005, all leading zeros or trailing zeros, what happens? Not good. There's only one significant number, that's 5. But that doesn't mean, like for instance, if you're doing a calculation, you still need those other zeros. So that's why we have the scientific notation. You can always write it in that format, 1 sig fig. And the last one on this set is 2.0. Or 2.900. It's after a decimal. So how many significant figures? Yes, that's right, it's 4. All right, last two. Calculate the correct number of significant figures. Additional problem, you add them all up, line up all the numbers right down to the decimal, add them all up, and you have this huge number. Now, what are we looking for in this one? Is it the number of decimals, or are we looking for the sig figs? Well, we're looking for basically the number of significant figures. There are 4, and so that would be 48.93. So 48.93, you're looking for significant figures. So in this case, in number 2, you have 32.27 times a 1.45, and that equals that particular number. What we really want to do is we want to round up to the least significant figure. So in this case, it would be, well, the least significant figure, 49.7. Because if you look, 1.15, that's the least significant figure. So we want our answer to reflect that. So what we would do, if you take a look at the 49.6958, that rounds up to a 7, because if you take a look at the 6, there's a 9 next to it. It means that the 6 can bump up to the next highest number, which would be 7. So, ladies and gentlemen, it's 3 significant figures, and I want to thank you so much for watching, and I hope this has helped you, and I'll see you in the lab. Thanks.